Okay, dear students, today we will start new chapter, that is acid, base and salts. Acid, bases and salts. See my dear students, there is large variety of elements. There are many elements. These all elements combine with each other. Combine means they chemically make bond with all the different elements, and what we get is compounds. Yes or no? As you all know, what is compounds? Any material that is made up of two or more than two elements, different elements. So there are many elements and all of them combine chemically to produce compounds. Very important. On the basis of chemical properties, these compounds are characterized or divided into the group of acids, bases and salts. See my dear students, very important. Acid, bases and salts is the groupism or the dividing the compounds. Okay, very important. It is different, means compounds are divided into three categories, that is acids, bases and salts. Now we will see what is acid, what is base and what is salt one by one. See my dear students, a little bit of touch we have already gone through in the 7th standard, that what is acid, it is sour in taste, bases are bitter in taste. So acids show acidic nature, or we can say any substance showing or having acidic nature is called acid. Any substance having basic nature is called base. Don't worry, what is salt we will see. Very important, any material neither showing acidic nature and neither showing basic nature, then such material is known as neutral. Very important. What is a neutral material or a neutral substance? A neutral substance does not show any of the basic or the acidic nature. Materials showing acidic nature are known as acids and materials showing basic nature are known as base. Any material neither showing the acidic nature, neither showing the basic nature are neutral substances. So, my dear students, first of all, we will see how can I find that any material is acidic in nature, how can I find that any material is basic in nature, and how can I find yes the given material is neutral or not. So for that, first of all, we will go through indicators. See my dear students, indicators. Okay. So what are indicators? As the name itself suggests, indicators indicate something. They give us a hint. Very important. What are indicators? These are substances, or you can say dyes. These are substances or dyes giving us hint or indication of telling any material. Very important. Substance dyes giving us hint or indication of any substance nature. Very important. Indicators are materials. Very important. What are indicators? See my dear students, these are indicators. Indicators are materials only or substances only. Generally, indicators are dyes. What they do is that, okay, if I put acid or base in them, or if I put this indicator into acid or base, they start giving some hint or indications. By this I will get to know that hint or acid, that material is acid or base. Very important, indicators give no indication for neutral substance. Very important. See my dear students, indicators only tell us whether any material is acidic or any material is basic. Very important, few indicators only tell us whether any material is acidic or basic, not give us the information about both the natures. And very important, if indicator is showing no effect or no change, it means that material is neutral. See my dear students, the general hint or indication is change in color. Change in color. See my dear students, you might have seen while driving, if I want to go to left side, I start giving the left hand side indicator, yes or no. If I want to go to right hand side, I start giving right hand side indicator, right side indicator of my vehicle. So indicator is giving a hint, and if I am getting no hint, or if I am giving no hint, that I am neither putting this light left and light rights, it means I am turning nowhere. So similarly, now we will see what are indicators one by one. Indicators, my dear students, are basically of two categories: natural indicators and synthetic indicators. Indicators, see my dear students, indicators are basically of three types. Sorry, two types. Indicators are basically of two types: natural indicators and synthetic indicators. See my dear students, in natural indicators there are many indicators such as litmus. If I am telling litmus, then I am talking about both the litmus solution and litmus paper. Turmeric, China rose, red cabbage, olfactory indicators, olfactory indicators. See my dear students, if I am telling you olfactory means these indicators give you the hint regarding a smell. Olfactory means related to smell. And in synthetic indicators, there are two main indicators. One is methyl orange and one is phenolphthalein. Phenolphthalein. So one by one we will see all the indicators. Okay. First of all, we will see natural indicators and then we will see synthetic indicators. The most common indicator which is being used in laboratory is litmus. See my dear student, litmus is present in both the forms, that is in solution form and in paper form. What is litmus? First of all, we need to see. We all know symbiotic relation of fungus and algae, that is lichen. That green material near the ponds, okay. That lichen, if you squeeze that lichen, you will get a liquid. If you squeeze the lichen, or you can say extract of lichen, is known as litmus, and this liquid solution is known as litmus solution. See, but as litmus solution cannot be carried at each and every place, for more simplicity, litmus is also converted into paper. So first of all, we will see litmus solution. Basically, the general color of litmus solution is purple. Very important. If we put acid in, this litmus solution, this color will turn into red. Very important. If acid, it will turn into red. My dear students, you just need to mug it up. You just need to create your own shortcuts to memorize all these things, because behind this, no need to go deep. Just memorize what changes of change in color is happening. And if we add base in litmus solution, the purple color changes into blue. Very important. Litmus solution, if you are adding acid into it, this purple color changes into red, and if you put base into it, then this color changes into blue. Very important, if I add any neutral material, very important, just for let's take pure water, no change happens. Indicators always give the hint regarding whether it is acidic or basic. See my dear students, if any neutral thing is added into any solution, sorry, any indicator, any neutral thing is added, no change will take place. You must keep this thing in my mind, in your mind. Okay, if we take litmus solution, sorry, litmus solution we have checked, done. If we take litmus paper, litmus paper. See my dear student, this is any solution. I want to find out whether it is acidic, basic in nature, acidic or basic in nature. Litmus paper are present in two colors. One is red in color, another one is blue in color. See my dear students, if we put red litmus paper into any solution and it converts into blue, then this is basic. This stuff is basic in nature. If I put blue litmus paper into solution and it turns into red color, then it is acidic. So very important, acid, blue to red. In base, red to blue. Very important. If I put a red colored litmus paper and it remains red, so what hint I will get is, then the question arises, then I will get two hints. If it is red itself, then either it is acid, as litmus is converted into red color in acid, but as it was already red, so either I will get the hint that it is acidic in nature, or if there is no change in litmus, it means it is neutral. To confirm whether this is either acidic or neutral, I need to put another litmus, that is blue litmus. If this blue litmus converts to red, then for guarantee it is acidic in nature. But if this litmus does not convert into red, then that material is neutral. Okay, my dear students, turmeric, as we all know, it is yellow in color. We very generally found at our food. We use turmeric very regularly in our foodings. Yes or no? Turmeric, it is yellow in color. See my dear students, if acid is put on turmeric, there is no change in color, it remains yellow. But if base is being added in turmeric, its yellow color changes into red. So very important question, my dear students, it is being asked in boards, that when we wash our white colored clothes and let's say any curry stain is there, as you all know curry is made up of, in curry turmeric is being used. So what they say is that there are, when while washing that white cloth which is having a curry spot, see curry means that which curry we eat, okay, so why we are finding red spots, very important, while washing we use soap and soap is a bit basic in nature, because of which the yellow color of the curry or the turmeric converts into red. Okay my dear students, China rose, the extract of China rose is red in color. China rose. Okay. The extract that we are getting from China rose is red in color. See my dear student, if you put this red material, China rose stuff, into acid, then what will happen is that this red color will convert into dark pink color, which we also say magenta color. Okay, and if this extract is put into basic solution, if this is being put into basic solution, what you will get is a, if you are getting, okay, china rose, you are getting red color, you will get green color, you will get green color. So very important students, turmeric was giving hint only and only for basic nature, litmus gives us hint for both acidic and basic nature, china rose also gives hint for both acidic and basic nature. Very important, any change in neutral, no change in neutral, you must keep these things in mind. Okay, now red cabbage, red cabbage, the extract of red cabbage is red. Very important, if you put this thing in acid, there is no change, it will remain red. But if you put this thing in base, this converts into green color. See my dear students, very important. China rose extract was also red in color and in base it was in green color, and red cabbage extract is also red in color and in base it is giving green color. But you can see it shows no effect for acid. Okay my dear student, now we will see olfactory indicators. What are olfactory indicators? In these indicators basically the substance or stuff. Now we will see olfactory indicators. What are olfactory indicators? Olfactory means related to smell. Related to smell. See my dear students, many materials change their smell, characteristic smell, or lose their characteristic smell in acidic or basic nature. Best example is onion and vanilla. When onion and vanilla, any acid is put on this onion and vanilla, there is no smell change. But if base is being put on them, what happens is that they will lose their original smell or characteristic smell. Lose their original smell. And this change, if onion and vanilla any material is being put on them and they lose their original smell, it means that material is base. Okay my dear student, in laboratory, to more common synthetic or artificial man-made indicators are also being used. Synthetic indicators. In synthetic indicators, two main indicators are there. One is methyl orange and one is phenolphthalein. See my dear student, methyl orange is from the name itself we can get this is orange in color. Methyl orange solution is orange in color. Its color is orange. Very important, if this methyl orange is acid is being added on this in this methyl orange, then the orange color converts into red. AOR, in acid orange to red. And if this is added into base, then this red color changes into yellow, that is BOY. If it is base, orange color changes into yellow. Phenolphthalein, this is a colorless solution. Very important dear students. Phenolphthalein is a colorless solution. So when any acidic solution is added into it, basically it remains colorless. If an acidic solution added into it, no change is there, it remains colorless. And if any basic solution or stuff is added into it, it changes its color into pink, or it gains a pink color. So very important dear students, these were indicators. indicators gives us hint about whether any material is acidic or whether any material is basic. Okay, my dear students, now we will start doing the topic acids. We will see what are acids, why acids have the acidic property, what are chemical properties of acids, what are categories of acids. Okay. So my dear students, first of all we will see acids. See my dear students, till now we know that yes, acids, these are materials which are generally sour in taste. My dear student, there are many types of acids. So basically from the origin point of view, from where do we get the acid? Acids are having two categories, that is organic acids and mineral acids. From where we are getting any acid, then on the base of that thing or the source of the acid, it is being categorized into organic acids and mineral acids on the base of strength. We will see when the complete topic of acids will be completed, we will see what is the meaning of the strength of acid. On the base of strength, acids are categorized into strong acid and weak acids, and on the basis of concentration or on the basis how much water is present in acid, then acid is categorized by the presence of water, how much water is present into it, into concentrated acid and dilute acid. See my dear students, acids are in these much categories. Where do we get from acid? On this basis, acid divided into organic and mineral acid. What is the strength of the acid? On that basis, it is divided into strong and weak acid. And how much water is present in the acid? Based on that category, it is divided into concentrated and dilute acid. So one by one, we will see all the topic one by one. So first, we will see what are organic and mineral acids. After that, we will see the chemical properties of acids, and after that we will see what is related or what is the meaning of strength of acid or presence of water of acid. These two things we will cover at the end of the acids topic. As of now we will see only this topic. Natural acids and mineral acid. See my dear student, the acids which we are getting from plants and animals, any acid which we are getting from plants and animals are known as natural acids, or any acid which is made up from the mineral of earth, or which is prepared artificially by man, that is known as mineral acid. Don't worry, now we will see what are natural acids. We all eat pickle, we all drink milk, we all eat fruits, citrus fruits, okay, we all eat spinach and many things. Pickle is having acetic acid in it, acetic acid, okay, milk is having lactic acid in it, citrus fruits are having citric acid in them, spinach is having oxalic acid in it, tomatoes also have oxalic acid in them, formic acid is present in non-sting. See my dear student, these all things we are getting from plants and animals, and all these things are consisting these acids. These all acids are known as organic acids. Very important, organic acid or natural acids. Mineral acids you can say inorganic acids. See my dear student, very important. These organic acids can be consumed by humans. Very important. These can be consumed by humans and these all are edible. These all are edible and we are getting them from the nature. Mineral acids are made from the minerals present in the earth and they are man-made. Hydrochloric acid, nitric acid, sulfuric acid. My dear students, these acids are man-made acids. Very important. Don't get confused कि sir hydrochloric acid is present in the stomach. Don't worry. It is also harmful for us if it is in excess amount. We know many times we get acidity because of this, and even to prevent our body from this, these acids cannot be consumed. Very important. These acids cannot be consumed and are very harmful. Very harmful. Our body, if they fall on our body will get harmed. Very important. Even in our stomach, for the protection from hydrochloric acid, mucus is being released by the stomach. So very important. Natural acids and mineral acids. See my dear students, natural acids we are getting from plants and animals. And these can be consumed by humans. Acetic acid, lactic acid, citric acid, tartaric acid, oxalic acid, formic acid, and mineral acids such as hydrochloric acid, nitric acid, and sulfuric acid. Very important. Sulfuric acid is known as the king of acids. Very important. Sulfuric acid is known as the king of acids. So these are being prepared by the minerals of the earth, and these all are man-made. Very important. Hydrochloric acid, nitric acid, and sulfuric acid cannot be consumed directly by us. Okay. So now dear students, one by one we will do the chemical properties of acids. At last we will see what are strong acid and weak acid, what are concentrated and dilute acid. Now one by one we will see the properties of acids. Properties of acids. See my dear student, first common property you all know, acids are sour in taste. This is very general property. Second, acids turns blue litmus red. Very important. You can use any indicators about any indicator you can write, but it is the best indicator is litmus. Okay. 3. Acid is good electrolyte. As you all know, if I am using the word electrolyte, it means a good conducting solution, or I can say conductor. How? Now we will see. See my dear students, if I am taking pure water, okay, you all know pure water is a poor conductor, okay, and I have put a wire. It is connected to a battery, and here it is bulb. This circuit is complete, current is flowing. Current will not flow, don't worry. This circuit is complete, but then too this bulb is not glowing. Why? Because of pure water. Because of pure water, and as it is insulated a poor conductor. What I observed is that when I added acid into water, okay, this bulb started glowing. It means first current was not flowing through here, and as I added acid, current I started flowing from here. Very important. It means acid is good electrolyte, and now you must get to know, if we are saying that current is passing through this solution, it means this acid is giving ions to the solution. Very important, because ions or the charge carriers are important for the flow of current. It means as we added acid, this pure water got ions. Second thing, these ions were free. You must get to know from this. So very important, acid is a good electrolyte. It means when we add acid into water, that water starts conducting. But by this we must also get that acid is having ions, and in water these ions are free. Only then the current is able to pass through it. If I add more acid this bulb flows more. Why? Current is very easily going through the water. Okay. See my dear students, already we know about this property that how acids behave with metals. How acids behave with metals. We already know metals get corroded by acids. How we will see? Now we will see reaction of acid and metals. Very important. Acids reacts with metals producing hydrogen gas. Very important. That is acid plus metal gives us salt plus hydrogen. Let's take a very common example. I am having sulfuric acid, okay, and now I have put zinc granules into it. When zinc granules go into it, what I observe is that bubbles of gases are going. Bubbles of gases are going. And when I burn these bubbles of gases, they burn with a pop sound. Very important. Burning with a pop sound is characteristic of hydrogen. Very important, my dear student. So we can confirm yes. When acid and metals come in contact, they produce hydrogen. This equation I am going to write. Acid H2SO4 plus zinc, that is metal, gives us zinc sulfate Zn2SO4 plus H2, and this H2 burns with a pop sound. Okay dear students, so now the question arises is here you get the hint why acids are never kept in metal container. Okay, here you must get to know why acids are never kept in metal containers. They are always kept in glass containers or ceramics. The reason is that even if they will be kept in metal containers, they will react with the acid and will get some another material. My dear student, this is also a corrosion process. When metal reacts with acid, it loses its property because it is no more a metal. Okay, this process is corrosion also. And if sometimes food is kept in metals, then also we get this stuff. This process known as poisoning of food. Okay, so very important, acids and metal if come in contact reacts, gives salt and hydrogen. Okay my dear student, very important, different metals give different salts. Okay, so very important, if metal plus hydrochloric acid reacts, then we get chloride salt of this metal plus hydrogen gas. And if metal plus sulfuric acid reacts, then we get metal sulfate of this, that is a salt and hydrogen gas. Okay, see my dear student, now we will see how acid reacts with metal carbonates and metal hydrogen carbonates. Very important, how acid reacts with metal carbonates and metal hydrogen carbonates. Reaction with metal carbonates and metal hydrogen carbonates. Oh, see my dear students, whenever metal, not metal, sorry, reaction of acids. Reaction of acids with reaction of acid with metal carbonates and metal hydrogen carbonates. That is acid plus metal carbonate or metal hydrogen carbonate. So what we get is salt plus carbon dioxide gas plus water. So very important, when acids react with metal carbonates and metal hydrogen carbonates, what we get is carbon dioxide gas. My dear student, let's take example. That is HCl plus metal carbonate Na2CO3, that is sodium carbonate. It is washing soda. What we get is NaCl plus H2 plus CO2. Very important, my dear students. Carbon dioxide gas always come out from liquid solution if produced in large amount with brisk effervescence. What is brisk effervescence? Actually, this is coming out of gas with a buzzing or fizzing sound. Okay, and reaction of hydrochloric acid with sodium hydrogen carbonate or sodium bicarbonate, this is washing soda, not this is baking soda. What we get is NaCl plus H2 plus CO2. See my dear student, very important, acids react with metal carbonates and metal hydrogen carbonate producing salt, water and carbon dioxide. The main thing is that reaction of acid and metal carbonate give us carbon dioxide gas. Very important, if question is asked how you will prove that this gas is carbon dioxide, first of all we can say the gas is escaping with brisk effervescence. This is a property of carbon dioxide. You produce in a large amount, it comes out from solution as brisk effervescence. Even though you can check or do carbon lime test, very important, if this gas is passed through lime water, the lime water turns milky, that is CaO2, that is lime water, and this is carbon dioxide. What we get is CaCO3, that is calcium carbonate, that is milky in color, plus H2O. Very important, my dear students, you must know this reaction. This reaction is very important. This carbon dioxide test is asked again and again, my dear student, very important. This carbon dioxide test is asked again and again, and you need to just mug up this. Okay, very important. Okay, see my dear student, how does an acid reacts with base? Now we'll see how an acid reacts with base. Acid reacts with base producing salt and water. Very important, that is acid plus base gives salt plus water. See my dear student, acid HCl plus base NaOH sodium hydroxide gives us salt, that is NaCl plus H2. Very important, here you can say in the product there is neither any acid nor any base. It means here acid cancels the effect of the base and base cancels the effect of the acid. That is, the material we are getting, it is neither acidic neither basic. It means the material is neutral. Very important. That's why this reaction is known as neutralization reaction. Neutralization reaction. What is neutralization reaction? It is a reaction between acid and base giving us salt and water. In this reaction, the acid cancels the basic nature and the base cancels the acidic nature, and the material which we are getting is neutral. My dear student, in next few topics we will also get to know that even in neutralization reactions also we are sometimes getting acidic or basic solution. What is the reason behind that? We will see. Don't worry. So very important. acid reacts with base producing salt and water. Now we will see how acid reacts with metal oxides. How acid reacts with metal oxides. Acid reacts with metal oxides giving salt and water. Very important, my dear students. Acid plus metal oxide gives us salt plus water. Very important. How? Let's take an example. We will take CuO, that is metal oxide, plus acid, that is HCl, gives CuCl2 plus H2O. Copper oxide plus hydrochloric acid gives copper chloride plus water. This is salt and this is water. So very important. Acids react with metal oxide to give salt and water. This reaction is very important to get to know some property of metal oxide. As we know, acid plus base also gives salt plus water. Acid plus base gives salt plus water. As you can say, the place of base, it is metal oxide. So very important, as base neutralizes acid, metal oxide is also neutralizing the acid, and metal oxides are basic in nature. You must get to know from it, metal oxides are basic in nature. Okay, my dear students. Now, as we know, acid reacts with metals, acid reacts with many things and give different products. That's why we say that acids are corrosive in nature. Acids are corrosive in nature. What does this mean? Acids are corrosive in nature. It means they react with many different materials. Different materials such as metals. When acid comes in contact with metals, the metals loses its property. This process is known as corrosion. So if we are saying acids are corrosive in nature, it means acids burn up many things, acids eats up many things, or acid destroys many things. Even if acid falls on our body, then our body gets many wounds, burnt wounds. Okay, so acids are corrosive in nature. It means acid destroys many physical and natural chemical properties of many substances, and they burn up many things, they eat up many things. Okay, so dear student, these were the properties of acids. Now very important, now we need to know why acids are acids. So first of all, we need to know what all the acids are having common in them. As we have seen the reaction, that is acid plus metals give us salt plus hydrogen, yes or no? It means metals, it means this is not hydrogen. And in product, if I am getting hydrogen, it means acid is having the hydrogen. So very important, what do all acids have in common? What do all acids have in common? So the answer is hydrogen. All acids have hydrogen in them. Very important thing. Whenever acid is added in water, or acid is in liquid form, all acids have hydrogen, and whenever acid is added in water or it is in aqueous form, it gives H plus ions. Very important, and these H plus ions are the main reason for acidic nature. Let's take an example. Hydrochloric acid, when put in water, it gives H plus Cl minus. This is the reason for acidic nature of hydrochloric acid. Let's take example of H2SO4. It gives H plus SO4 minus. Acetic acid CH3COOH gives CH3COO minus plus H plus. So very important, all the acids contain hydrogen. This hydrogen, when acid is in water or in aqueous form, this hydrogen is in acting as H plus and it is a free ion. Now we will come to know what is the reason for conductivity or being a good electrolyte of the this acid. The reason is that, let's take an example. If I put in water hydrochloric acid, then I get two ions, that is H plus and Cl minus. These two ions pass the current. That's why acid is a good conductor. Second thing, all the acids have hydrogen, and acids have this property whenever they are in aqueous or water solution, or in water, then they dissociate or they give H plus free ions, and these H plus free ions are the main reason behind the acidic nature. Now very important question arises, do all the materials having hydrogen are acids? The answer is no. Example is glucose, alcohol, all this stuff have hydrogen. Glucose is C6H12O6, C2H5OH, that is alcohol. Very important. If I put these things in water, glucose remains this complete molecule and it does not dissociate any H plus ions. Even if I put alcohol in pure water, that is C2H5OH, even this is also not dissociating any H plus ion. But when I am putting any acid into it, let's say nitric acid HNO3, as soon as this comes into this water, it becomes H plus and NO3 minus. If I am putting hydrochloric acid, that is HCl, it will become H plus and Cl minus. These are free, these are acting as free ions, and this H plus free ion is the main reason for acidic nature. That's why if glucose or alcohol being added into water, they will not pass the current through it. But if it is added into water, acid passes current through it. The reason is that it gives H plus free ions. Very important thing is this. See, all acids contain water, not water, all acids contain hydrogen. But all hydrogen containing compounds are not acids. All hydrogen containing compounds are not acids. All acids have hydrogen, but all the things or all the material having hydrogen are not acids. You must get to know this. Now we will see what are strong acids and what are weak acids. See, my dear student, strong acid and weak acid. In a simple language, as we know, acid means H plus ions. Very simple. Acid means H plus ions. So if I am adding any acid, okay, into water, if I get large number of H plus ions, then it is a strong acid. And if I am adding any acid and I am getting less number of H plus ions, then that is a weak acid. We will see how. Let's take two different beakers having water in them. Okay, this is pure water, both of them. In this, I am adding strong acid. Let's take nitric acid. It gives me H plus ions. And if I am adding acetic acid in this, it also gives H plus ions, but less than nitric acid. That's why acetic acid is a weak acid, whereas nitric acid is a strong acid. Or you can say strong acids ionizes fully, whereas weak acid do not ionize fully. Do not ionize fully. I will let you know. Let's take nitric acid, hydrochloric acid, sulfuric acid means mineral acids are strong acids. Except carbonic acid. Carbonic acid is a mineral acid, but then it is also being a mineral acid. This is exception, that is carbonic acid. Carbonic acid is mineral acid, but it is weak acid. All other mineral acids are strong acid. That is HCl gives H plus Cl minus. Whenever strong acids are being added into water, they fully dissociate and give large number of H plus ions. But if we are adding any weak acid into water, they give H plus ions, but they do not ionize fully. That is, you can see the difference in the arrow. CH3COOH gives CH3COO minus plus H plus. H plus we get, but what happens is that this again converts into this. As it converts into this, 50% or more than that again converts into this. The reason is that we are getting this is the reason we are getting very less H plus ions. So the thing is that strong acid and weak acid, it is a category based on the strength of the acid, and very important. In strong acids we are getting large number of H plus ions, and in weak acid we are getting less number of H plus ions. The reason is that both of them ionizes. One is dissociating or ionizing partially, and one is ionizing fully, completely. Okay, so now we will see what is concentrated acid, what are concentrated acids, and what are dilute acid. Concentrated and dilute acid. See my dear student, same acid is concentrated and same acid is dilute. Same acid can be concentrated or same acid can be diluted. How? Basically concentration and concentrated and dilute acid, basically this thing is depending on availability of water in the acid. Okay. See my dear student, if we are having water, okay, and I add acid into it, so I am having H plus ions, so now I add water into it, 2 liter water, 3 liter water, 4 liter water. First it was having in 1 liter, it was having 10 H plus ions. Then I added 20 liter water. Then in 20 liter water, so much large amount of water, there are 10 H plus ions. Yes or no? So the thing is that here in the 1 liter 10 H plus ions were there, that is per unit volume more H plus ions are there. Such acid is known as concentrated acid. If in concentrated acid water is being added, then what we get is diluted acid. What is diluted acid? In diluted acid, per unit volume H plus ions are quite less. Very important, the process of adding water or diluting the solution is known as dilution. Very important. In dilution, few things need to be taken care of. The main thing is that this is acid, this is water. While diluting, we must add water in acid or acid in water. Very important, dear students. This must be taken very care of. Acid, if you are adding water into acid, it is very much risky. Why? When you add water in acid, heat is released. Okay, and when acid is being added into water, then when heat is being released, the thing is that drop by drop you are adding acid into water, so heat is released. But very important, this heat is absorbed by water and there is not too much difference. But if it is acid and you add water into it, then all of a sudden a lot of heat will be released. Okay, and acid cannot absorb that much heat, and either the water, if you are adding into it, that heat will make that water into vapor. All of a sudden expansion in vapor will be there and your test tube may break. So very important, you must add acid drop by drop into water, not water into acid. Okay, my dear student, so this was your basic thing regarding acid. Okay, now we will see that what is the okay, now we will see what are bases. Now we will see what are bases. See, my dear students, as we all know, we have generally gone through many times, but bases are such materials or substance or compounds which are bitter in taste. Okay, this is very general thing we as of now know. See, my dear students, basically, as we get to know that acids are acids because and only because these are the compounds which dissociate H plus ions into water, or they are having H plus free ions. Similarly, bases are also materials which gives OH minus ions. Very important. First of all, now we will see one by one what are bases. See, my dear students, now this thing that what they give we will see before itself. Bases are compounds that are generally bitter in taste. Very important, metal oxides or metal hydroxides are bases. Very important, we will see metal hydroxides, that is NaOH, KOH, MgOH2, CaOH. As you can see very easily, these all things are bases. See, my dear students, very important, even metal carbonates and metal hydrogen carbonates also show basic nature. As you have already seen that when acid reacts with this, they give salt and water, yes or no? That's why metal carbonates and metal hydrogen carbonates, they also show basic nature. Very important, what are bases? Bases are generally bitter in taste. Metal oxides and metal hydroxides are bases. NaOH, KOH, MgOH, these all things are bases. Now very important, many times at the name of bases, alkalis or alkalis is being used. What is an alkali? Very important. Alkali is a base, but very important, my dear students. All the metal hydroxides or all the bases do not dissolve in water. Bases which dissolve in water are known as alkali. In 10th standard, if you are doing any experiments with bases, just getting that all are alkalis. Okay, examples are sodium hydroxide, potassium hydroxide. Okay, magnesium hydroxide. Magnesium hydroxide is also known as make of magnesia. We will see, don't worry. Now we will see what do all the bases have in common. What do all the bases have in common? Okay, very important, my dear students. All the bases have OH minus, that is hydroxide. Very important. When bases are added into water, or whenever they are in liquid form, or whenever they are aqueous, they give OH minus free ions. Very important. All the bases have OH minus free ions. These OH minus free ions are the reason for basic nature of base. We all know that acids are showing acidic nature because of H plus ions, and bases are showing basic nature because of OH minus ions. So very common way we can get to know that what are strong acids and what are weak acids. Similarly, we can say what is concentrated or dilute base. First of all, we will see what is a strong base and what is a weak base. See, my dear student, both the bases, whether it is strong or weak, gives us OH minus ion. But if any base is dissociating large number of OH minus ion, it is strong base, and any base is dissociating less number of OH minus, then it is weak base. Okay, very important. If strong base is being added, example is sodium hydroxide, it gives many OH minus ions. But a weak base such as magnesium hydroxide is being added, it gives less number of OH minus ions. So very important, strong base and weak base are based on the strength or the ability to give more number of OH minus ions. The reason is that strong base ionizes fully, whereas weak base ionizes partially. As it is partially ionizing, it is giving very less number of OH minus ions, because of which it is weak. Okay, my dear students. Now, very important thing which you need to know about acid and base is, as at the word of base, I told you that we will be using the word alkali. Why? Why only that base which is able to dissolve in water, we are taking only those bases? The question arises, why? Even in acids, acid in solid form and gaseous form show no acidic nature. Again the question arises, why? Very important, dear students. All the acids have H plus ions. All the bases have OH minus ions. Very important. But if acid or base is in solid or gaseous form, they are unable to give H plus or OH minus ions. Now very important thing is that these H plus ions and OH minus ions must be free, then only they will show their nature. Very important. Let's take an example how. See, in solids, you know, ions or particles cannot change their position. It means H plus or OH minus are not free. Very important, to show whether anything is acidic or basic, the acid or base must have ions, but that also free. Let's take an example. Let's take a beaker. and add sulfuric acid H2SO4 into it. Okay. Now add some salt into it. Add some salt into it. NaCl. So H2SO4 plus NaCl will give Na2SO4 plus HCl. Very important. H2SO4 plus NaCl will give Na2SO4 plus HCl, and this HCl comes out as a gas. Very important. Now this HCl, hydrochloric gas, after hydrogen chloride gas, I am telling you this is gas. Okay. Now what happens is that I want to check whether this is acidic or not. Obviously HCl is acidic, we know. But as this is in gaseous form, I put a litmus paper that is blue in color. But when this litmus paper comes in contact with gas, there is no change. Why? But then I brought a wet means it is any water in it, wet litmus paper, blue litmus paper, and when that wet blue litmus paper comes in contact with HCl, it turns red. This activity shows that whether it is acid or whether it is base, it doesn't matter. It matters whether it is able to dissociate H plus or OH minus free. Okay, very important. Acids are not able to show their nature in solid or gaseous form. Bases are also not able to show their effect in solid or gaseous form. They are only able to show this effect when they are in liquid form or they are present in any aqueous or water, aqueous solution, or they are in form of water. Okay, my dear students. Now we will see properties of bases. Now we will see properties of bases. One by one we will see all the properties of bases. Properties of bases. Okay. First property we all know, bitter in taste. Bases are bitter in taste. Second, this is very common thing we must know. Bases are slippery or soapy in touch. Okay. Bases are slippery or soapy in touch. Very important. Base converts red litmus into blue. Fourth, bases are good electrolytes. We know why, because they give OH minus ions. That is, if I am having water, okay, and this connection is there, this is the bulb, okay. If it is pure water, this bulb does not glow. But as soon as I add base into this or an alkali into this, it starts conducting current and this bulb glows. This shows that whenever base is added into water or whenever it is in aqueous solution, it gives free ions. It means it is a good electrolyte. And what are those ions? Those are OH minus ions. See, my dear students, the main thing is that the fifth property is this, that how does bases react with metals. Okay, my dear students, very important. Few bases, not all the bases, few bases reacts with few metals. Very important. Few bases reacts with few metals. Not all the bases reacts with all the metals. Very important. Because this reaction is a very complex type of reaction. Okay. So my dear, let's take an example. Sodium hydroxide, basically whenever if base reacts with any metal, what we get is salt plus H2 hydrogen gas. So NaOH if sodium hydroxide, that is base, is reacted with zinc, what we get is Na2ZnO2 plus H2. Very important, my dear student. This is sodium zincate. This is sodium zincate. Very important. In sodium zincate, here the metal, now it is present in negative ion, not in the positive ion. That is ZnO2 2 minus ion. Very important. And that H2 gas produces an pop sound if you want to check its presence. Okay. Now, how do bases react with acids? We all know bases reacts with acid, producing salt and water. Producing salt and water. Bases reacts with acids, producing salt and water. Okay, my dear student, that is base plus acid gives us salt plus water, and we all know this reaction is neutralization reaction. Why? The reason is that in such reactions base cancels acidic nature and acid cancels basic nature. So if anything is neither acidic or nor basic, then it is neutral. That's why this process is known as neutralization reaction. Example is sodium hydroxide plus H2SO4, that is sulfuric acid. We get Na2SO4, that is sodium sulfate plus water. Very important. Now, my dear student, question arises: why, whenever any acid reacts with base, we always get any neutral product? Very important. As we all know, bases give OH minus. Okay, or bases are having OH minus ion free, and acids are having H plus ions free. So as these are free, this H plus and OH minus, they are oppositively charged, they attract each other, and H plus plus OH minus gives H2O. H2, 1 to 2 hydrogen and oxygen, and this H2O is water, and there are no more H plus or OH minus ions, because of which we get a neutral product. Very important, my dear students. Whenever neutralization reaction takes place, the OH minus free ion of the base combines with H plus free ion of the acid, and because of which, as both of these combine, and now there are no more H plus or OH minus free ions, and the acidic and basic nature cancels or dies, and we get a neutral product. Now, dear student, this is very important thing you must get to know. Okay, now we will see how bases reacts with non-metallic oxides. How bases reacts with non-metallic oxides. Reaction of base with non-metal oxide. Let's see. Base reacts with non-metallic oxide, giving salt and water. How? That is base CaOH2 plus non-metallic oxide, that is carbon dioxide, gives CaCO3 plus water. This is calcium carbonate, that is salt, a white colored precipitate, and H2O. This is also the same reaction which we do for the presence of carbon dioxide. See, my dear students, in previous property we did that base plus acid gives us salt plus water. So very important, base plus acid gives us salt and water, and base plus non-metallic oxide also gives salt and water. It means non-metallic oxides are acidic in nature. Very, very important. See, my dear students, eighth property, they are also, that is, bases are also a bit corrosive. Also a bit corrosive in nature, means too much strong bases must not be taken directly into hand for a longer period. See, my dear students, now we need to see the usage of acids and bases. In our general life, there is a lot of use of all these things, that is acid and bases. Usage of acids and bases. There are many uses of acid and bases. Sulfuric acid, it is being used in batteries. Okay, bases are used in making soaps. Acids are also being used in making those cleaning stuff in our washrooms, and bases are being used making in rayon. Sodium hydroxide is being used to make rayon, that is a artificial synthetic fiber. Okay, so in our general life there are vast and variety uses of acid and bases. Acid and bases are also being used in making fertilizers. Okay, so the general thing is that in our daily life we are using many acids and bases. Our toothpaste are made up of bases, washing stuff, and our vim bars, when our mother washes the dishes, that time that thing is a bit acidic in nature. Okay, along with that, the washing powder which mothers are using and the baking sodas, they all are bases. So the thing is that in our daily life there are a large use of acids and bases. Okay, my dear student, now we will see pH scale. This pH scale tells us about the strength of acid and base. Strength of acid and base. See, my dear student, let's take an example. Let's say this is pure water. It means it is neutral. H2O. Okay, that is, if it dissociates, H plus OH minus, yes or no? If I add acid into it, H plus ion increases. If I add acid into this water, it becomes acidic, yes or no? But even though if it is acidic, you can see OH minus is present into it. Okay. Now if I add base into it, then OH minus increases. I add more and more base. So now it is basic in nature. But being basic in nature, then also you can see H plus ions are present. So very important, whether it is base or whether it is acid, both the ions H plus or OH minus ions are present in the solution. But if H plus ions are more, then it is acidic, and if OH minus ions are more, then it is basic. What the thing is that pH scale is a scale which tells us about the strength of the acid or base by using only and only the number of H plus ions. If H plus ions are less, it is basic. If H plus ions are very large in number, it is acidic. We will see, don't worry, we will go through that. What is pH scale? pH scale tells about the strength of acid and base. pH scale consists of only numbers. It consists of numbers only. pH scale is having number from 0 to 14. Very important. The number of pH scale is inversely proportional to concentration of H plus ions. Don't worry, it means pH scale only tells about the concentration of H plus ions. That is, if concentration of H plus ions is more, as it is inversely proportional, number on pH scale will be less, and if H plus ions are lesser, then number on pH scale will be more. Don't worry. Number 7 is neutral. That means it might be having H plus ions, it might be having OH minus ions, but the H plus ions and OH minus ions are same in number. Very important. Even if these both the things are not present, no effect. Even if they are present, here H plus ions and OH minus are same in number. Okay. So it is having pH 7. If H plus ions are more, if H plus ions are more, the number on pH decreases. Very large number of H plus ions, very small of number of pH. So if the pH decreases, see, if the number on pH decreases, H plus ions increases, and as H plus ions increases, now you can see OH minus is there, but H plus ions are more, so pH below 7 is acidic. Okay, at 7 it is having H plus and OH minus same, but if OH minus are very large, then if OH minus are large, it means H plus is less. If concentration of H plus is less, then the pH is more. It means if pH increases from 7 or it increases more and more, it means OH minus concentration increases, or if the pH number is increasing, means the concentration of H plus ions is less. H plus decreases. As H plus decreases and OH minus increases, pH above, any substance having pH above 7 is basic. See my dear students, from pH 3 to 4, below 7, any substance having pH below 7 is acidic in nature. Why? Because below 7 the H plus concentration is more. 3 to 7 are considered as weak acids, and 0 to 3 are considered as strong acids. Why? The concentration of ion is very large, because of pH is very less. 7 to 10 are considered as weak base, and 10 to 14 are considered as strong base. Why? As we move from 7 to 14, H plus decreases and OH minus increases. OH minus increases, it becomes base. OH minus increases a lot at 14, a very strong base. At 0 to 1, you will find hydrochloric acid. Okay. At 13 to 14, you will find sodium hydroxide. Very important. Hydrochloric acid and sodium hydroxide are weak acid and weak base respectively. Okay, my dear student. As you have understood pH scale, now you also need to understand universal indicator. Universal indicator, very important. Universal indicator. Okay. As we all know, what are indicator? Indicator gives us hint whether anything is acid or base. See, my dear student, we know what are indicators. They tell us whether anything is acidic in nature or whether anything is basic in nature. But they don't give any hint whether anything is strong acid or weak basic. For example, indicator can tell me yes, acetic acid is acid and hydrochloric acid is acid. But indicator cannot tell me about whether acetic acid is having more H plus ions or less H plus ions or strength of that. It will never tell me that hydrochloric acid is more strong than acetic acid, but there is an indicator known as universal indicator. As you all know, what are indicators? They tell us about whether anything is acidic or basic. But my dear student, this universal indicator, along with anything is acidic or basic, also tells about the strength of the acid and base. So very important. What is universal indicator? Universal indicator is a combination of dyes which tells us about whether anything is acidic or basic along with the strength of that acid and base. Universal indicator is present in both the form, that is solution form or paper form. See my dear students, if we are using any universal indicator, on universal indicator colors are being indicated along with the pH. Let's say example, for red the pH is 14, for black color the pH is 7, for green color the pH is 1. So very important. Let's say I am using universal solution paper, universal paper. If I put that universal paper into any solution, and if that universal indicator paper becomes black, and I'll get to know yes, its pH is 7, it means it is neutral. If I put that indicator paper, universal indicator paper into this solution and it gives green color, then I will not only get the hint that it is acidic in nature, I will also get to know that it is having pH 1, it means it is strong acid. Okay, and if I put that universal indicator paper into this solution and I get red color, it means I will get the hint that this solution is a base and very strong base with pH 14. Okay, my dear student. Now, what are the uses of pH in our daily life? My dear student, pH plays a very important role in our daily life. We will see. Only knowing something is acid or base, that is not enough. We also need to know the strength of that material. We also need to know the strength of that material. Uses of pH in our life. Uses of pH in everyday life. See my dear students, as we all know, pH means it is a thing which gives me hint of the strength. First is digestive system or digestion. If pH in my stomach falls below 2, then I will start feeling acidity. I will have a sense of burning in my stomach. Okay, and if pH of my digestive system is lesser, means higher, that is 6 or 7, and there will be no issue. Second thing, tooth decay. Very important. As we all know, this is our teeth, and the food we eat remains in our mouth. So very important, this food is acted by bacteria and converted into acid. If this acid is having pH of 6 or 7, or you can say 5, means below 7 and above the 5, then it will not affect above 5.5, not 5. Then it will not affect too much. But if it is below 5.5, and we know it is our teeth is made of calcium, it will start corroding and holes will be created. Okay, cavities will be created. pH of plants and animals. That is, my dear students, regarding plants, if we are doing agriculture, then our soil must be neutral. we need to check our pH of our soil. If it is too much acidic or too much basic, then we must make it neutral. If it is acidic, we must add lime, and if it is basic, we must add normal compost, because that compost degrades and it converts into a bit acidic material and your soil becomes neutral. Many animals, such as in sea or aquatic animals, you need not to throw all the stuff into sea, or you need not to throw all the thing into ponds and all. Why? If that waste is either acidic or basic, so if that thing goes into water, the best thing is acid rain. Okay, during acid rain, the pH of the water in aquatic things falls a lot, because of which those animals are not able to survive, because they are habitual to live in neutral water. Okay, and the bit change in pH is okay, but when the pH changes a lot, and that those animals are unable to survive. My dear student, even many animals are using this acid or base for self defense also. Okay, such as bee sting, wasp sting, and these are the common things or everyday pH uses in our life. Okay, my dear student, now we will see what is salt. Okay, salt is a thing which we get when acid reacts with bases. Acid plus base gives me salt plus water. As of now, forgot the water. Very important. What is a salt? Salt is a compound we get when any acid reacts with any base. I will give you an example. Hydrochloric acid plus sodium hydroxide gives me a salt, that is NaCl. Now very important. It means any salt have two parents, that is one base and one acid. See my dear student, one more example I will give you. H2SO4 plus NaOH gives me Na2SO4. This is also salt. Now you need to understand, this is acid HCl, this is acid H2SO4. A metal from base takes the place of hydrogen in the acid, and what I get is NaCl. And it was hydrogen, now it is Na metal. H2SO4, hydrogen of acid, now it is being replaced by the sodium of this NaOH, and I get Na2SO4. That is, what is metal? We get metal when acid, when in acid hydrogen is replaced by any metal. Very important. In any acid, if hydrogen is replaced by metal, then what we get is salt. Very important, my dear students. NaCl, Na2SO4, CaSO4, these all are salts. Most important thing, most important thing, even by acid we must able to get to know, sorry, even by the salt we must be able to get to know by which base or which acid we have got that salt. For example, we know this is salt, instead of metal here was an hydrogen of any acid. So if we put hydrogen at the place of metal, we will get the acid, and if that metal is combined with OH, then we get the base. So even by salt we can get their parent bases and acids. Very important. In salt, the metallic part is written first and the non-metallic part is written later on. Okay, my dear student, very important. There are many salts. See, let us take 4 to 5 example. Hydrochloric acid, sulfuric acid, carbonic acid, nitric acid, acetic acid. If hydrogen of hydrochloric acid is replaced by any metal, then we will get a salt, that will be any metal chloride. If hydrogen of sulfuric acid is replaced by any metal, we will get metal sulfate, that is a salt. If hydrogen of carbonic acid is replaced by any metal, we get a salt. Okay. If this hydrogen of nitric acid is replaced by any metal, we get a salt. Very important, my dear students. If hydrogen of this acetic acid replaced by any metal, what we get is any salt. Okay, my dear students. I'll give you one or two example. Metal chloride, NaCl, sodium chloride. Metal sulfate, that is CaSO4. Okay. Metal carbonate, CaCO3. Sodium chloride, calcium sulfate, calcium carbonate, these all are salts. Okay. Chlorides, sulfates, carbonates, nitrates, acetates, all these are salts. We get salt by any acid, when any acid combined with any base. See, my dear student, it is being found that many times the salt we are getting, that is showing a bit acidic or a bit basic nature. Why? So very important. See, my dear students, whenever acid reacts with any base, we get salt plus water. Okay. That is, acid gives H plus and this gives OH minus. This H plus, if there are 10 H plus and there are 10 OH minus, then we get 10 molecules of water, yes or no? Okay. If there are 100 H plus and we get 20 OH minus, then this 20 OH minus reacts with 20 H plus and we get 20 H2O, but still 80 H plus are left in solution. So very important, in this solution H plus free ions are present. So at that time the result I am getting is acidic salt or acidic solution. Similarly, if there are more OH minus or less H plus, then we will get a basic salt solution. Why happens so is the reason is ions. Very important. If strong acid reacts with strong base, we get neutral salt, because H plus and OH minus are almost same. But if strong acid reacts with weak base, see, strong acid have large H plus ions, yes or no, and weak base have less OH minus ions. So these H plus will combine with OH minus and we will get water, but still as the H plus ions are very large, the salt we will get, no issue, salt we will get, water we will get, but as H plus ions are very large, still there will be few H plus ions, free H plus ions in the solution, and we will get a acidic salt. Similarly, if strong base reacts with weak acid, what we get is basic salt solution. Why? Strong acid means, strong base means large number of OH minus ions, yes or no? And weak acid means less number of H plus ions. Even if these H plus ions combine with the same number of OH minus ions, but then also there will be few OH minus free ions in the solution, because of which you will get a basic salt solution. Okay, my dear students, now we will see salts, usage of salts, what common salts are present in the. Okay, students, now we will see few of the salts, their sources, and what are their uses. See, my dear student, the most salt, even called as a common salt, most common salt is sodium chloride, which we also call as table salt, and we use daily. Sodium chloride, that is NaCl, we call it as common salt. We all know this is a salt having crystal shape. Okay, what does this crystal mean is that these all are having straight boundaries and sharp edges. This is crystal shape. Okay, see my dear student, NaCl is a white colored salt. Okay, very important. In laboratory you can prepare it by sodium hydroxide plus hydrochloric acid giving NaCl plus H2O. Okay, so this is common salt. Moreover, mostly you get this salt from sea. Sea is source of many salts, but NaCl we get from sea. Sea water is being put into open fields and let to evaporate. When the water evaporates, we get NaCl solid crystals on the land or field. Very important. We also get it by mining, that is, we get it in the form of rock salt. Okay. See my dear student, sodium chloride is a very useful salt. It is used for cooking in our daily life. Very important. This salt is also important for our body movements into our body. Second thing, this sodium chloride is also used for preservation of food. That is, sodium chloride is being used for preserving fish, meat, and many other things. And very important, we are getting many other chemicals from sodium chloride. Now we will see how sodium chloride is giving us many different materials, and how we are using those different materials to get many other things. See my dear student, salt solution, that is NaCl plus water. Okay, so NaCl plus water, or the concentrated, highly concentrated solution of salt, is known as brine. Very important. What is brine? That is concentrated NaCl, that is concentrated salt solution. See my dear student, when brine's electrolysis is done, or electrolysis is done of concentrated NaCl, see NaCl, sodium chloride, and water, and when its electrolysis is being done, this is negative terminal, that is cathode. Don't get confused between cathode and cation. Cation are positively charged ions and cathode is negative terminal or negative electrode. This is positive electrode, that is anode. Okay. See my dear student, as electrolysis is done and this is a solution, yes or no? As we add salt, it gets converted into Na plus free ion and Cl minus free ion. As it is in aqueous solution, these ions can freely move. And water in electrolysis dissociates into H plus and OH minus. See my dear student, now one by one how many things we will get. This is positive ion, that is Na plus, and this is negative and that is OH minus. They will attract and form NaOH. It is a base, that is, it is caustic soda, sodium hydroxide. Second thing, H plus and Cl minus. Okay, it will produce HCl, that is hydrochloric acid. So we are also getting acid. See my dear student, these are the parent acids and parent bases of NaCl. I told you the equation. From salt NaCl we are getting base, we are getting acid. Now very important, this H plus ion gets attracted towards the negative ion to get the electrons. Okay, so very important, we get hydrogen gas here. Very important, we get hydrogen gas here. Second thing, this chlorine comes at positive electrode, so we are getting chlorine gas here. Very important. See my dear student, how many products we are getting. See my dear student, along with it, one more special type of product we are also getting in this in this process, that is NaClO, sodium hypochlorite. We are also getting NaClO, that is sodium hypochlorite. Sodium hypochlorite. See my dear student, from a single NaCl we are getting NaOH, that is base, we are getting HCl, that is acid, H2, that is gas, Cl2, that is gas, chlorine. Okay, we are getting NaClO, sodium hypochlorite. So very important, NaCl salt gives many other products for industries. NaOH is known as caustic soda. It is used in the preparations of soap. It is used wherever base is being used, because it is a base. Hydrochloric acid, it is used for cleaning metals. It is used for cleaning metals. It is used for giving chlorine gas in industries. It is also being used to neutralize any base. So very important, these are usages of this. NaClO. My dear students, wherever you see chlorine, just get that thing is very useful. Why? Because that thing can be used for bleaching. If I am using the word bleaching, means I am directly talking about chlorine. So this is a bleaching agent, NaCl, that is sodium hypochlorite. Okay, chlorine gas. Chlorine gas is being used for chlorine gas is being used in many places. Chlorine is used to prepare bleaching, that is bleaching powder. Okay, hydrogen H2 gas, it is also used for many preservations or different thing. Moreover, liquid hydrogen is being used as rocket fuel. So my dear students, NaCl, it is a salt. NaCl has many uses such as cooking and all. Along with that, it is also being used to prepare a lot many things by the process of electrolysis of brine. By the process of electrolysis of brine, NaCl and H2O, in that Na dissociates into Na plus and Cl dissociates into Cl minus free ions. H2O dissociates into H plus and OH minus. Na plus OH minus forms NaOH, H plus Cl minus forms HCl, and these Cl2 Cl minus ions come and accumulate and giving Cl2 chlorine gas. H plus ions accumulate at cathode giving us H2 gas. Okay. So my dear student, along with this, there are also many other uses of sodium chloride or brine. We use sodium chloride or brine to get washing soda or baking soda. Very important. How? Now we will see. Brine, okay, brine or NaCl. I am using the word brine. It must be concentrated and cool. When brine, carbon dioxide gas is passed, okay, in presence of water and ammonia, NH3, we get a very useful product, that is NaHCO3, that is sodium hydrogen carbonate, and along with that we get ammonium chloride. We get NaHCO3 plus NH4Cl. Okay, my dear student, very important. This is baking soda. This is baking soda. And even if we heat this baking soda, we get Na2CO3 plus H2. This is washing soda. Very important. See my dear student, from sodium chloride brine, when carbon dioxide gas is passed in the presence of ammonia also being put into it, what we get is baking soda. We will see uses of baking soda. And if sodium hydrogen carbonate is heated, we get Na2CO3, that is washing soda. See my dear student, baking soda NaHCO3, sodium hydrogen carbonate or sodium bicarbonate, it is used for baking. Very important my dear student. Baking soda and baking powder are different. Baking powder are different. Basically, baking powder is a mixture of baking soda plus any mild acid, tartaric acid. Why? When we use sodium hydrogen carbonate or baking powder, it is having baking soda as main ingredient. When we heat it and add water into it, what we get is Na2CO3 plus H2O plus along when it combines with water. When it combines with water, actually, if you want to bake anything, very important, it must be a bit wet. Along with that, it must be having a bit heat. That's why you call it baking. So it gives carbon dioxide gas along with the base. This is Na2CO3. It is a basic in nature. Yes or no? By carbon dioxide, our thing starts getting fluffy. Okay, its volume starts increasing, but this base gives a bitter taste to the cake or pastry, whatever you are preparing. So what happens is that baking powder is basically a combination of baking soda. Baking soda is for giving CO2, okay, that gas to make it fluffy, but along with CO2 it also gives a base. The thing is that this base now reacts with this acid and no bitter taste is present in that stuff. Okay, my dear student, NaCO3 baking soda, it is also used in fire extinguishers. Why? We know Na2CO3 metal carbonate and NaCO3 whenever they come in contact with acid they give carbon dioxide, yes or no? So what is that? If this is any bottle of fire extinguisher and NaHCO3 baking soda is being put into it, the thing is that along with it here is a thread and in a tube acid is being put into it. What happens when we pull this up? This acid mixes with this acids fall down, combines with baking soda, acid plus NaCO3 baking soda gives a lot of carbon dioxide and that carbon dioxide is used for extinguishing the fire. Washing soda, it is used in detergents. It is used in detergents, very important. Washing soda destroys the permanent hardness of the water. Destroys the permanent hardness of the water. So very important my dear students. By salt, by adding carbon dioxide and ammonia in the brine, we get baking soda and ammonium chloride. Baking soda its many of the uses, very important. Along with that, if we heat this baking soda, what we get is Na2CO3. Very important, my dear student. Original formula of washing soda is Na2CO3 dot 10H2O. This is the original formula. But if we heat it, this water evaporates, goes away, and you get Na2CO3. This is known as soda ash. This is anhydrous salt. Okay, not anhydrous metal carbonate. Originally 10H2O, then this is washing soda. Okay, my dear student. Now we will do bleaching powder. First of all, we must know what is meaning of bleaching. Okay. See my dear student, bleaching is a property to remove color from any cloth. Now we will do bleaching powder. See, what does bleach mean? Bleach means to remove color. For example, I am having this blue t-shirt. I put it into water. I add the bleaching powder. When I take it out, most of its color will go. So that process is known as bleaching, and disinfectant means to kill germs. Very important. Both these works are being done by bleaching powder. When lime water, that is calcium hydroxide, is and chlorine gas is passed through it, that this chlorine we are also getting from the NaCl hydrolysis, sorry, brine electrolysis, yes or no? We get CaOCl2 plus H2O. This CaOCl2 is our bleaching powder. See my dear student, actually you need to mug up the formulas. These formulas are very important. This CaOCl2 is bleaching powder, very important. Bleaching powder, okay. Bleaching powder is used for bleaching. It is also added in water to kill the germs, very important. This bleaching effect is because of the chlorine, most important. Even by bleaching powder we can get chlorine gas. How? By adding bleaching powder to acid, it releases chlorine. Memorize my dear student, bleaching effect is of chlorine because chlorine is having oxidizing property, very important, okay. Moreover, we cannot take chlorine gas very easily each and everywhere, but we can take bleaching powder along with us, okay. So if I am having bleaching powder, means originally I want to say I am having chlorine. So bleaching powder is prepared by calcium hydroxide, and when chlorine gas which we get from the brine electrolysis, when we pass it, we get CaOCl2 plus H2O. This CaOCl2 is calcium oxychloride, and this is only the bleaching powder. Bleaching powder is used to get chlorine. Bleaching powder is used many places to bleach the clothes. Moreover, if you use the bleaching powder for washing sweater, memorize, if you use this part, it will not let the sweater get shrinked, very important. Bleaching powders does not allow the things to get shrinked up, okay my dear students. Now we will see one more salt, that is calcium sulfate. Calcium sulfate, okay. Now we will see gypsum POP. Our main concept is POP, that is plaster of Paris. See my dear student, formula of plaster of Paris is CaSO4 dot half H2O. Don't worry, the concept behind half H2O we will see. See my dear student, this thing you generally might have seen many times nearby you. You might have even heard the name gypsum. It is very much being used in the cement factories and cement material stuff. So what happens is that, see, gypsum is a material whose formula is CaSO4 dot 2H2O. Gypsum is hard, okay. If we heat gypsum in kink, okay, heat it at around 100 degrees Celsius, what we get is CaSO4 dot half H2O plus 1 upon half H2O. See my dear student, this is only our plaster of Paris, POP. It is powder, white powder. See my dear student, again if I add water in POP, it becomes gypsum, it becomes hard. And if I heat the gypsum about 100 degrees Celsius, I get the POP. Very important. Heating this above this will make lose even this molecule of water, and we will get an anhydrous POP that is not that much useful. See my dear student, first of all you must get to know how can a single molecule of CaSO4 can deal with the half molecule of water. Having half molecule of water is not possible. What happens is that CaSO4 one molecule, CaSO4 second molecule, both of these molecules share a single molecule of water. It means single molecule of water between two CaSO4. It means CaSO4 half H2O, or you can write 2 CaSO4 dot H2O. No issue. You can multiply this completely by 2. Okay. Now see my dear student, plaster of Paris. Plaster of Paris, we get it by heating it in the kink. By heating gypsum, we get plaster of Paris. Where is plaster of Paris used? It is used for doing or that setting up the bones, fractured bones, setting up the fractured bones. It is even used as our luxury or beautifying our ceilings. Beautifying our ceilings. It is also being used for making statues. What happens is that when we add water to POP, it converts or hardens into gypsum. But the thing is that its volume increases a bit. That's why it is used for making the statues. See my dear student, this is white colored powder. So see how heating gypsum gives POP, give it whatever shape you want, make it wet, again you will get it hardened form. So these are uses of POP and all the things. See my dear student, now very important thing is water of crystallization. Water of crystallization. What is this water of crystallization? See my dear students, FeSO4.7H2O, CaSO4.2H2O, CuSO4.5H2O. Very important. Now we need to know what is water of crystallization. Very important. Crystallization. Actually, my dear students, salts have a crystal shape. Salts have a crystal shape. Very important. That shape is because of the reason is that their structure is having water molecules on them. Water molecules on them. These water molecules are not, we cannot see them, and neither these molecules of water are not on the salt. Okay, they are part of the crystal shape. Very important. They are part of the crystal shape and they do not evaporate. So the thing is that salts have water molecules as a part of their crystal structure. That water is known as water of crystallization. Example is CuSO4.5H2O, CaSO4.2H2O, FeSO4.7H2O, okay, Na2CO3.10H2O. See my dear student, these all are having water molecules. This water molecule is part of their structure. Okay. Now the thing is that these water molecules are reason for the crystal shape. These are the only main reason we give the crystal shape. Moreover, this water is also the reason. This water crystallization also the reason for the color of that salt. As CuSO4 is having blue color, the reason is this dot 5H2. So what happens if I heat this salt a lot? See my dear student, if we heat these salts a lot, let's take example CuSO4.5H2O. This is having crystal shape, okay, and this is blue salt, okay. If we heat it up, heat a lot, what happens is that this water of crystallization escapes and we get CuSO4 plus 5H2O, not dot H2O. Here it is part of the shape, here it is now escaped from the structure. Now this CuSO4 is no more having any crystal shape. Now it is just like simple powder, talcum powder, so it's soft, okay. And second thing, it is now white in color, it is not having any more blue color. Very important. If we add water in this, again it will get back its water of crystallization, get back its shape, and will get its blue color back. This salt having water of crystallization is known as hydrated salt. Hydrated salts have water of crystallization. Along with that, as the word itself says, hydrated, and salts do not having their water crystallization known as anhydrous salts. When anhydrous salts are added water into it, they get back the crystal shape. This is also known as crystallization process. What is crystallization process? It is the process giving back the crystal shape. Now very important, even this process and this thing can be used to find the presence of moisture in the air. How? If I get powdered CuSO4 at any place and after 1 hour or 2 hour, this white powder converts a bit into blue color, it means this white powder anhydrous salt has somehow got some of its molecule have got water. It means that water is present in air. So very important. You can even use this test for finding out the presence of moisture. So our chapter is complete.